Okay, so this is Mr. Wyrick. Today we're going to be going over the 8.2 review. I've got Desmos pulled up here, so we're going to take a look at what we're doing. So the first four problems are all based on braking distance. Now when you do these on the test, it's going to be multiple choice, and it's going to give you this formula and tell you how fast they're going. So all we have to do is put the formula in. So as I type it in, I've got 2.2, and it's supposed to be V, but I'm just going to use X. It missed my decimal there. 2.2 times X plus, I hit the divide, it makes a fraction. Oh my gosh, it's doing it all in the wrong place.
Does putting the X in parentheses change it at all?
No.
Okay.
So I've got 2.2x plus my division sign. I've got x squared over, in this case, 20. So it's going to give me a nice quadratic equation. If I zoom out far enough, I can see how it loops down. But the only thing that's going to make sense here is the positive. Like, it's not like you can really go negative miles an hour. You can drive in reverse, but you still have a positive speed, not a negative speed. So this front part here is the only part that's really going to matter. I can actually come down on this next part and just go x equals, and the first one it gives me is 55. So if I'm going 55 miles an hour, I have to zoom out a bit to see that. There's my 55 miles an hour. You can see what's happening to my braking distance as I do that. So when I click on there, I got that intersection, and it's 272.25. So that's going to be my braking distance, is 272.25 feet. The very next one says 35, so I'm just going to change this 55 to a 35, and then I come over here, I can see it's 138.25. The next one is 75. I change that 3 to a 7. Might need to zoom out a bit more. My intersection is over here at 446.25, so 446.25. And then 20 miles an hour is obviously going to back that down quite a ways. Here's 20. I just moved my graph a little bit, and 20 is at 64, so it's only going to take me 64 feet to stop. On number 2, the braking distance is the exact same formula, so you have to be very careful in what it's asking for and the information that it's giving you. When it tells you that this is how fast you're going, you put that in for X. When it gives you this is how long it takes you to stop, you need to put that in for Y. So I'm going to change this X equals to a Y equals. And the very first one says I've got 100 feet of stopping distance. So that 100 is going to cross through in two different places. The first one is a negative 71.84, which doesn't make any sense at all. The other one is right over here, 27.84. So I'm going to say that's about 28 miles per hour. Okay? I'm not looking to get super exact, and you'll have multiple choice. So it'll have a decimal place or something on it to where you can see it. The next one says my stopping distance is 200 feet. I back this down, change it to 200, and again, I'm looking for this positive one. It's 44.96, so I would probably call that 45 miles per hour. The next one tells me that my stopping distance is 500 feet, so I change this to 500. I take a look, and it's going to be 80.3, so I'd probably just call that 80 miles per hour. And then the last one says it's going to take me 1,000 feet to stop. I've really got to be booking for it to take me 1,000 feet to stop. I'm going to have to zoom way out. And when I get up here, I see it's 121.122. So I'm going about 121 miles per hour. Again, on your test, this is going to be a multiple choice question. It's going to have options for you. But just so you know what it is you're looking for, the X equals or the Y equals. Number 3, the gravity problems. It's negative 16t squared plus vt plus h, where v is the upward speed of the object, h is the starting height. All of the problems that are on the test, no matter which version you have, no matter which question it's asking you, if it's doing a rocket, that rocket is firing off the ground. So it's not going to have any starting height, it's just going to have upward velocity. So I'm going to go ahead and delete both of these. We'll see what we're looking at. but this is going to be a negative 16, and again, I'm going to use x instead of t, negative 16x squared. So then my upward velocity on the first one is plus 160x. There it is. Very, very narrow, because this is only measuring the amount of time that it's in the air. It's not trying to graph the path. So it goes up, it hits the peak, it comes back down, and the amount of time it takes is going to be right there at 10 seconds. Okay? Which is a fairly long time when you think about gravity. The next one says it's 180, so I delete the 160. I put in the 180 instead. It's not going to change much. That's going to be 11.25 seconds for it to hit the ground. Again, you don't want to go with the 0, 0. That's not helpful information. It's not going to take it 0 seconds to hit the ground. The 200 feet per second, I delete the 180. I changed it to 200. We come back down. We take a look, and it's 12.5. So that's 12.5 seconds. And then the 260 feet per second, I'm just going to delete this and put a 6 in that place. When I go and take a look at it, that's 16.25 seconds. So it's really a lot of just substituting into the formula. Again, on the questions, on the test, it's multiple choice. The formula should be there. You should be able to see it. You should be able to work it pretty simply. Number 4, when the object is dropped, we're not going to have any upward velocity, okay? This is when you roll a ship out to where you want it to be and you drop anchor. How long is that anchor going to take to hit the water? If it's like the video that we watched where the guys were throwing the stuff off the tower, they're not tossing it up into the air, they're just dropping it. So we have no upward force, but we have a starting height. So I'm deleting the x and coming up. So now my vertex is always going to be right here on 0, and it's just going to go down like this. Okay? So when I take a look at the first one, drop from 110 feet, I just go plus 110. And you can see it move up. You can see that it starts to take longer to come out. And here's my zeros still. That's going to be 2.62 seconds for the 110 feet. For letter B, 250 feet, I change the 110 to 250. It goes higher. It's going to take longer to drop. And when we look down here, it makes the point for me, 3.953. So I'd probably just call that about 4 seconds. 600 feet is obviously going to take longer, but it's not linear, okay? This is a curved graph. This is a quadratic graph. So it's still curving downward. It's not really going to be like double the amount of time, even though it's more than double the height. So this is 6.124 seconds. And again, I'm not going to be looking for this kind of precision as far as decimal places. You'll just have to kind of pick the best answer because it'll be on there in multiple choice format. And then the last one, 30 feet. I back this way up. It's going to take almost no time from 30 feet. So we look here, and yeah, it's just over a second if you drop it from 30 feet. I think 30 feet would be, if you came out here on the top of the school on this back side and dropped something, how long would it take it to hit the ground? So it'd be just over a second, okay? 1.369 or just like 1.4 seconds. Okay? Make sure you understand this stuff. Make sure you know how to enter it in, what you're looking for. That'll get you moving in the right direction, and good luck on the test.